Ever stop to truly look at your ring, your necklace, or even the circuit board inside your phone? That glimmering gold isn't just a pretty metal. It's a cosmic traveler. Its atoms having journeyed across unimaginable distances. Each tiny speck, every single gram, once rode the raw, violent shockwave of a collision so bright, so powerful, it briefly outshone a billion suns. Sounds wild, right? Well, buckle up, because in the next few minutes, we're going to chase that gram of gold from the very edge of the universe all the way into your pocket. This isn't just a story about an element, it's an epic tale of creation born from destruction. So where does this incredible journey begin? It starts in the most extreme cosmic graveyards imaginable, with neutron stars. Think of a neutron star as the ultimate cosmic zombie. It's the super-dense, collapsed core of a massive star that already lived a spectacular life and then exploded as a supernova. Imagine something only about 25 kilometers wide, roughly the size of a city, yet packing more than twice the mass of our entire sun into that tiny sphere. That's why a sugar cube of this stuff would weigh about as much as Mount Everest right here on Earth. These aren't static objects, though. They're often spinning hundreds of times a second, and sometimes, two of these incredible cosmic remnants find themselves locked in a gravitational dance. For hundreds of millions, even billions of years, they orbit each other, slowly, inexorably spiraling inward. Gravity, that persistent force, always wins in the end. As they draw closer, their monstrous masses warp the very fabric of space-time, sending out ripples known as gravitational waves. Then, in 2017, humanity actually heard that cosmic scream. The LIGO and Virgo detectors chirped, signaling the detection of gravitational waves from such a merger, an event dubbed GW170817. Telescopes around the world swiveled, capturing the incredible kilonova flare that followed, an explosion roughly 1,000 times brighter than a typical nova. This single breathtaking event, 130 million light-years away, didn't just confirm a theory, it created something truly precious. Scientists estimate that collision alone pumped out roughly 50 Earth masses of pure gold, along with other heavy elements like platinum and uranium. It was a literal gold mine in the sky, proving that these mergers are the dominant source of heavy R-process elements in the universe. So how do you turn a maelstrom of neutrons into something as beautiful as gold? It's a process of extreme alchemy. In that split-second smash-up, temperatures hit hundreds of billions of degrees Celsius. The environment is so utterly chaotic and dense that free neutrons swarm like frantic commuters in a rush-hour subway, latching onto atomic nuclei faster than radioactive decay can ever hope to knock them off. This incredibly rapid neutron capture, what scientists affectionately shorten to the R process, is the universe's ultimate heavy element forge. It builds elements heavier than iron in mere seconds, transforming lighter nuclei into a dazzling array of heavier ones. Gold in this cosmic drama is the polite passenger that jumps on last. It's stable enough to survive the ride, a perfect atomic structure forged in the heart of this cataclysm. Without those colliding neutron stars, the periodic table of elements would literally stall at lead. Imagine a universe without gold, platinum, or uranium, a much less sparkly and perhaps less interesting place. Once forged, those newborn gold atoms don't hang around. They ride a radioactive cloud expanding at an astonishing 19,000 miles per second, flung out into the vast emptiness of space. For a few millennia, this incandescent cloud cools, gradually merging with interstellar gas and dust. This enriched dust then becomes the cosmic fertilizer, seeding the next generation of star systems. Fast forward a few billion years, and some of that gold-infused dust condensed into the very nebula that eventually gave birth to our sun, our Earth, and ultimately, us. But here's the kicker. When our young planet was still a molten ball, most of that precious terrestrial gold, being incredibly dense, sank deep into Earth's fiery core. It's still there, locked thousands of miles below our feet, an inaccessible treasure. In fact, estimates suggest there's enough gold in the Earth's core to coat the entire planet in a 4-meter-thick layer. So, if most of Earth's original gold is trapped in the core, how did we get the accessible gold we mine today? Well, our planet got a cosmic re-blinging. Accessible gold arrived late in Earth's history, during a tumultuous period known as the Late Heavy Bombardment, roughly 4 billion years ago. This was a chaotic era, when a relentless hailstorm of metal-rich asteroids and meteorites pummeled the young Earth, effectively recoating its crust with a fresh veneer of precious metals. Geologists have traced this incredible event by studying the isotopic fingerprint of crustal gold. It matches the composition found in meteorites, not the Earth's mantle or core, providing compelling evidence for its extraterrestrial origin. These meteoritic sprinkles were then stirred and concentrated over eons by Earth's dynamic plate tectonics, creating the veins and nuggets that people would eventually find and unearth in locations like the Yukon's icy rivers, the rich mines of South Africa, or the California goldfields. When you look at your wedding band or any piece of gold, you're not just seeing a pretty bauble. You're holding atoms that survived neutron star chaos, navigated interstellar winds for billions of years, endured violent asteroid impacts, and rode volcanic eruptions to the surface. Every glittery speck is a souvenir from the universe's most extreme forge, a testament to cosmic resilience. It's a profound thought, isn't it? When you feel its weight, you're literally holding concentrated cosmic violence, transformed into something beautiful and enduring. Yet, this product of such cataclysmic beginnings sits politely on your finger, never rusting, quietly outlasting civilizations, a silent witness to our history, and a tangible link to the universe's most spectacular events. It's a symbol of permanence, born from the most transient and explosive moments in space. Gold's journey took more time than Earth has even existed. It's a powerful reminder that the wildest, most destructive explosions in the universe don't just obliterate. They create value, beauty, and even the very elements we still treasure today. So next time you glimpse something golden, pause for a moment. You're not just seeing a shiny piece of metal. You're seeing the luminous echo of 2 dead stars that slammed together, flung fortune across the vast cosmic void, and ultimately made bling possible. If this story just rewired your brain with a sense of cosmic wonder the way it rewired mine, do me a favor. Tap subscribe and ring that bell so you don't miss the next incredible cosmic origin tale we unravel together.